All right, so 9.2 on reflections. This is our second rigid motion. Again, the common word for reflection would be a flip. So we're going to flip our images. So they will remain congruent, same size, same shape, but the orientation will definitely be different. The positioning will be different. Okay, so here's our definition for a reflection. So a reflection across a line, which is called the line of reflection, has the following properties. If the point is on the line, if point A is on the line, then the image of A is itself. A prime and A are the exact same point, as you can see right there. But if B is not on the line, then the line M is the perpendicular bisector of segment B, B prime, of the segment connecting the pre-image to the image. This idea is huge. I need you to understand this. So if this is B, right, my pre-image, and this is my line of reflection, then if I connect B to B prime, two things should be true. Number one, that segment should be perpendicular to the line of reflection, which is. And secondly, the distance from my pre-image to the line should be equal to the distance from my image to the line. Perpendicular bisector. Very, 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 very important. Okay. You can do the same thing with C, right? Look, if I connect C and C prime, again, perpendicular, and the distance from C to the line is the same as C prime to the line. Now, in our function notation, you'll see the capital R will stand for reflection, okay? And you might see that on Delta Math. Okay, so again, just to emphasize this function notation, so again, R y equals x is a reflection across the line y equals x. And again, you might see R with a an object in the parenthesis. That means you're going to reflect that object across the line, written as a subscript. So some properties here. Again, reflections preserve distance. Reflections preserve angle measure. So, segment AB is congruent to segment A prime B prime, as we're showing here. And angle, let's say ABC, is congruent to angle A prime B prime C prime, as we're showing here. So this is another example of a rigid motion, which means your pre-image and image are congruent. So triangle ABC is congruent to triangle A prime, B prime, C prime. Very, very, very important. Okay, good. And again, I cannot emphasize enough this idea of this perpendicular bisector, right? Line M is the perpendicular bisector of segment B, B prime. Okay, so now most of our stuff is going to be on the coordinate plane. So here are some common reflections on the coordinate plane: x-axis, y-axis, y equals x, and y equals negative x. I have set up an activity on Desmos geometry, so I'm going to show you that now. But we're going to see, do our pre-image of x comma y, does it become these images? So first, for the x-axis, x comma y should become x comma opposite of y, right? A negative here means opposite. So the negative symbol equals opposite, not negative. Because again, if you are already negative, you're going to become positive. You're going to become opposite. Okay, so let's take a look here. So if I go to Desmos geometry, here's my coordinate plane. I'm going to put a point at 3, 2. We're going to call that point P. So that point right there is point P, and it's at 3, 2. P. Okay, so I'm going to transform this. And as you can see, I have a couple reflections here. I don't know if I can delete them. Yes, there we go. Okay, so let's define our transformation across the x-axis. So let's go ahead and label the x-axis green. Let's define a transformation. It's going to be a reflection across that line. Boom. So now I'm going to take my point P and I'm going to reflect it across that line. And there is my P prime, my image. Let's call this P prime. And what are its coordinates Coordinates. Its coordinates are now 3, negative 2. The y became opposite. And what did our notes say? The y would become opposite. So it matches. Okay, let's do the y-axis now. So I'm going to delete that point. I'm going to make that blue. Let's make the y-axis green now. Let's go into our transform. Let's delete this. Okay, so now let's define a transformation or reflection across the y-axis. All right, let's take point P, let's reflect it across the y-axis, and boom, there's our image P prime. What happened this time? Well, this time your x became opposite and your y stayed the same. That's what's going to happen when you reflect across the y-axis. When you reflect across the y-axis, the x-coordinate switches opposite. Okay, now what about this line y equals x? Okay, well, let's go ahead and graph that here. Let's delete that point. Let's put our y-axis back to blue. Let's delete this transformation. Okay, so the line y equals x means that every point has the same x and y coordinates. So 0, 0, 1, 1, 2, 2. That's the line y equals x. We're going to make that line green. And now let's define that reflection across this line. Okay, so I'm going to take point P and reflect it across that line. And boom, there's P prime. P prime now has the coordinates. Well, now I'm going 2, 3. So the coordinates of P prime are just the switching of the x and y of the preimage P. And that's exactly what our notes say. To get y, when you reflect across y equals x, the x and y switch. The x becomes the y becomes the x. That's exactly what this line says. Y equals x. Y becomes x becomes y. All right, last one, y equals negative x. So let's see if you can piece this together, right? I'm going to delete this line and these points. If those points were on y equals x, then what do you think is on y equals negative x? Well, it's all the points where the x and y are opposite of each other. So 0, 0 is still on the line, but negative 1, 1, x is negative, y is positive. Negative 2, 2, x is negative, y is positive. There is the line y equals negative x. Let's color it in green. Let's go to our transformations. Let's define a reflection. Let's define a reflection across this line. Okay, and now let's take P and let's apply it. And boom, here is P prime. And what are the coordinates of P prime? Well, now it's negative 2, negative 3. So notice your x and y still switched position, right? But now they both turned opposite. And that's exactly what our notes say. When you graph across the line y equals negative x, the x and y switch places and they both become opposite. And that's what this says. Y equals the opposite of x. So they switch and they become opposite. All right. So again, you might want to keep these rules, maybe on like a little cheat sheet, piece of paper, so that you can look at them quickly as you go through the problems. All right, so I will go through your Delta Math assignment, doing specific problems as I see fit. That'll be in another video.